Okay, so we're moving forward with the 289 build, and last week's video we did all of the machine work on the engine block. And today we're gonna go through and resize the connecting rods and then get them mounted on our new cast hyper-eutectic pistons. So let's see if we can't get started on these rods and make them brand new again. So typically what you'll see in a connecting rod on the big end as far as wear is that a lot of the force is in this straight up and down direction here on the housing bore of the rod. So if anything, what will happen is they'll actually get almost stretched or worn a little bit, and they'll be a little bit too large in this dimension right here. So the process for repairing these is to grind a little bit of material off of the mating surface of the cap and the rod here, and then when we bolt that back down together, the housing bore is now smaller than the factory specification, and we can go back in and machine it back to the factory diameter. We are also going to go ahead and install a set of ARP bolts in these connecting rods just to make sure that they are as good as they can be when they leave the shop. Our machine that we use here to grind the mating surface of the rod and the cap clamps the rod on the thrust side of the rod, and then the cap surface sits here against this bar, and that gets everything aligned and square so that when we run across this stone here, we're removing an even amount of material and we're machining it perpendicular to the thrust side of the connecting rod. But a lot of times, maybe a rod has gotten banged up along the way, or during the cleaning process, maybe it had a little bit of a burr raised on there. So before I do any of the cap machining, what I like to do is just run all of those surfaces on the file so that we can take off any sharp edges that may cause the rod to sit uneven or be clamped, unevenly in that fixture. And yes, I know this is not the right way to use a file, but this is what works. See that one, I don't know how well the camera will pick this up. You'll see these shiny edges right there. That's what I'm trying to take off, because that could have caused the cap to sit kind of at an angle when we're trying to machine these surfaces. This is a CBN wheel here on our cap grinder, and it should already be adjusted from the last time I did connecting rods to take just about the right amount of material off of the cap and the rod here. But I'm gonna cut one rod and cap and torque this one rod and cap and measure it and see if it is cutting the right amount of material off before I cut the other 7. And it's shiny all the way across, so we did clean up. Now I'll discuss this feeler gauge a little bit later on in the video, but this is something that not every shop agrees with, but this is how we do it here in our shop. And like I said, I'll talk about that a little bit later on. Looks good. Now I'm just going to break this sharp edge here so that when we install our bearing inserts, we don't scrape up material on that sharp edge on the back side of the bearing. Just like that. Put a little bit of our ARP lube on the bolt. Just gonna start it. And I'm just gonna use the vise to push the rod bolts into the rod, if I can. It's a little tougher than some. Man, I might have to use the press on these. I think I'm gonna have to use the press on the rest of them. Yeah, I'm gonna use the press on the rest of those. Make sure the mating surfaces are clean. According to ARP, these should be torqued to 35 foot-pounds using their Ultra Torque lubricant, which we've got installed. So we need to set up our bore gauge to be able to measure this. Go to our trusty bearing catalog. For a 289, the rod bearing spec for the housing bore should be 2.239 and 0/10 to 2.239 and 8/10. So they give you an 8 thousandths tolerance, or 8/10 thousandths tolerance there. So we'll set up our micrometer to 2.239 0, and then use that to set our bore gauge to where 0 is the low side of that tolerance. So we have 4 thousandths to hone there. And at the sides, you'll see it didn't pull in the sides super tight, but we still have 1/1000th to go to our minimum finish size. So we should be able to cut all the rods and caps, and unless there's one that has something funny, we should clean up okay. So we'll run through and cut all the caps. So now we're going to do the rods. But on the rods, we do what is called angle cutting. And what that is we take a small feeler gauge and we put that under one side of the rod, and we cut a little bit of an inward angle on that side. Then we flip it around, do the same thing, and cut a small amount of inward angle on the other side. And what that does is when you torque down the cap, it actually pulls in the sides just a little bit. It's not a lot, but just a little bit, so that when we put this back in the hone and hone it out, we're actually getting a perfectly round bore. Now, there are guys on the internet that will tell you that's a bad thing because they think that it stresses the rod bolts, but every time that I ask, I never have had anybody that can tell me, A, whether they have had a proven rod bolt failure as a result of angle cutting the connecting rods during the resizing process, or B, can prove to me with some empirical data or some measurements that that actually does cause a significant amount of strain on the rod bolts. We've been doing it in our shop for over 40 years, haven't ever had any issues, so that's the way we do it, like it or not. Okay, I decided let's go ahead and use the press to get these bolts in, since they go in a little bit tight. nice and slow like that. Threads are all lubed up, and the underside of the nuts are lubed up. So I'll just start these on. £35. So luckily, the last set of connecting rods that I did uses the same mandrel here as what we're doing today, so I don't have to take the time to switch out the mandrel. We've got our rough stone installed in here for roughing the rods out close to the finished size, but I still do need to do a little bit of setup here to get the machine ready to go for these rods. The brass shoes here, we need to adjust those to the curvature of the connecting rod. And the way we do that, take one of our rods, slip it over, and we'll loosen the hold downs, bump it back and forth a little bit, and tighten these back down. So those shoes are kind of almost the supports or guides for the opposite side of the honing mandrel from where the stone is contacting. So you just want those to be adjusted to roughly the curvature of the connecting rod. Like I said, I've got a rough stone in here. The next thing we need to do is set up our power stroke attachment. And the last rods we did were a little bit thicker than these. Loosen these. And we'll bring the outer nuts up till they just touch. Back off one flat, and then tighten it up from the back side. And now we have enough clearance to just slip the rod in there, but it's going to hold it to guide it back and forth across the honing stone. And the last thing, once we've adjusted that, is to adjust the stroke length so that it overstrokes evenly on both sides of the stone, on both sides of the connecting rod. So there I'm just a little bit past the screw. There I'm not quite past it, so I'll adjust this out up a little bit. Just about to the edge of the screw. Right about there should be good. And now we should be ready to start honing. So this honing stone is just an abrasive stone. I describe it as kind of being like sandpaper, and the rougher stone here is going to remove material from the inside of the bore pretty quickly, but it's not going to leave a very nice surface finish, and it's a little bit harder to hit a really tight tolerance with the rougher stone. So we're going to start with that. Then we'll switch over to a different stone that is a little bit finer grit after we're within maybe a 0.5 of our finished size. So this one I've got about 3 to 4 thousandths to remove. I'll adjust our oil here. The oil kind of washes away the grit that stone is going to be breaking down, as well as all of the metal grit that is coming out of the inside of the rod. The rod bore is going to be, basically the oil is just going to wash all of that away. By flipping the rod back and forth, it helps the stone wear evenly, which helps in turn keep your connecting rod bore from having any taper or barrel shape or hourglass shape. Hourglass would be where it's tighter in the middle and wider on the edges. Barrel would be the opposite of that. And then obviously taper would be, larger on one side than the other. Because we want this to come out perfect, there's always a tolerance, but perfectly round and perfectly straight from top to bottom. See it. We're around 4 or 5 tenths, and that needle's not moving a ton from side to side. Every single small mark there is 1/10,000th of an inch, or what we refer to as a tenth. So we've got about 5 tenths to the minimum finish size. And realistically, our tolerance goes from 0 to 2 tenths this way from that number 1 in the green there. So with the rough stones, I'm gonna leave this one right there. And you can see kind of the finish that it leaves. So this one, to start with, is not quite as round. We've got about 2/1000ths out of round here. So this knob here lets me turn down the cutting pressure. When you're running a lower pressure, it doesn't cut as fast or efficiently, but it helps straighten out an out of round situation like we've got going on here. And we'll just ease into it here, or else you kind of tie up the mandrel and belt slips and it doesn't sound very nice. So just to show you here, hopefully the camera will pick this up. We've cleaned up all the way over here, but we're leaving just a little bit of shadow there towards the parting line, which is not a huge deal, but probably that will clean up by the time we get to our finished size here. So that's pretty good right there. And yeah, like I said, it's cleaned up at the parting line. This knob here controls how far out the stone can come. So when I turn it down there, I'm actually making the mandrel smaller essentially, so that when we start honing here, we're not tying up the stone with it being a little bit out of round, like I said. Okay, so now we're gonna switch to our finished stone. This is the rough stone, this is the finished stone. So the finished stone is just a finer grit. Takes a little longer to remove material, breaks down a little bit faster, but does a nicer job. I'm still gonna run pretty low pressure. We have an 8/10,000ths tolerance. I'm gonna try to be about 2/10,000ths inside of spec, meaning 2/10,000ths bigger than the smallest that this could be. So there's about one. You know, I might even give it just a little bit more than that. Not much, though. Kind of in that 2 to 3 realm. Usually we're used to working with only a 5/10,000ths tolerance, so that's where we go kind of right in the middle. But even though we have 3 more tenths to work with, I'm still gonna kind of size it in that 2 to 3 tenths range. Again, I don't know how all the camera is gonna pick it up, but there's the finish. This is a rough finished rod. This is a finished rod. So you can see the surface finish difference. Okay, so now I'm gonna let them cool off. I'll come back in 10 or 15 minutes, double check our mic, or double check our bore gauge with the mic, and then we'll double check all our rods. But they might need touched up a tenth after that, but we're pretty well finished resizing the rods. Let's double check one more time, 2.239. So anywhere from 0 to 8 little marks that direction is acceptable. Looks good. Looks good. Looks good. Looks good. Looks good. I bumped something. Okay, those came out good. Really good. Okay, say that again.
Well, looking at the old cam here, the nose of it here just a little bit pitting, a little bit along the side here.
Yep.
It's really not that bad.
Well, the lifters all looked pretty good. There was maybe one or two that you could see some wear starting on it. But for people who are watching, you're getting ready to send this off to Delta Cams to be reground.
Yes.
Because we ended up deciding with the customer, we don't want to, when they're wanting to keep this thing pretty much bone stock. That was the desire of the build from the beginning. So we've decided it's not worth spending the money to go to a roller when you're just trying to keep it stock anyway.
There was a little bit of discussion about going to a roller, but it adds so much expense to the engine. I mean, it more than doubles the cost of the parts to build the engine just to do the conversion to roller.
That's a lot of labor on the heads and so on.
Yeah, to do it right. And on top of it, even the mildest rollers I see out there on the market are performance grinds.
Yeah, and that's not what they were looking for.
That's not what we're after on this.
So this camshaft is in such good condition, just like the rest of the engine was.
Yeah.
I mean, the story was 125,000 miles, but it looked great.
Yeah, and it's not good enough to put back.
No.
It needs to be...
But it's good enough to send off and have it reground.
It's an excellent core.
So we're sending this off. Hopefully Delta Cams, maybe they'll even take some video of the process a little bit, and we can include that in our video. Get her packed up and sent off?
Okay, we'll do.
So we are balancing this, and I remembered that I need to weight match my pistons and rods. The casting looks pretty clean. I don't know how to explain that. It looks like it was a nice mold. So hopefully it's not too crazy here as far as balancing goes. So let's start with the pins. 142.6, 142.6, 142.6, 142.6, 142.5, 142.6, 142.5, 142.6. Okay, in other words, the pins are all the same, so we don't need to do any mixing and matching with pins. Honestly, I'm just gonna put them all back in, and we'll just remeasure the piston and pin combined and go from there. I didn't expect them to be far off, but never know. 784.8, 784.0, 784.0, 785.0, 784.6, 784.4, 784.6. Of course there's one that's super light, but maybe we'll end up with a rod that's heavy. 783.5. So when you're balancing your connecting rods, you actually need to balance the big end and the little end separately. So this fixture allows us to measure each end individually. 165.4. We'll go through and do all the small ends first. 167.5, 164.7, 167.8, yikes, 168.1, 167.5, 166.7, 168.0. Now I'm going to flip this around and we'll do the big end. 392.4, 391.6, 393.5, 397.8, 394.9, 393.7, 397.1, 391.4. So it looks like our pistons vary by 1.5 gram. Our rods vary by 3.3 grams on the small end. So even if we paired up, you know, the heaviest small end with the lightest piston, we're still going to come out about 1.5 grams different. I'd like to be at least under 1 gram. Even though it's a stock application, I just like to get it as close as I can. So we're going to have to remove weight from the heaviest rods. Start with number 2 and see where we come out. So this extra bit of material right here is the balance pad. That's where they intend you to remove material from these when you're balancing. Kind of interestingly, on the top side, looks like they just milled out. I've never paid enough attention to these, I guess. A lot of times the balance pad sticks out about this far. These, they've milled out a groove there. I don't know that we want to remove very much material from those. Number 7 needs a few grams removed. Number 3. Number 1. Number 8. Okay, we've got one piston here that is about 1 gram heavier than, so I'm going to take a little bit of material off of it. Same thing on number 4. So I'm getting things laid out here so that we can get all of the pistons installed on the correct rods and in the right orientation. When it was all said and done, after messing around a little bit with the balance, I mean, this thing really wasn't crazy far off to begin with. The small ends of the connecting rods, we ended up, across all 8, were about 1.2 grams difference. On the pistons themselves, we're about 1.1 grams difference. But by the time you mix and match the lightest small end rods with the heaviest pistons, and vice versa, you come up with a difference of 0.6 grams. So under 1 gram is severe overkill for what this is, but again, YouTube, so here we are. On the big end side of the connecting rods, I think we had a difference of, the difference on the big end is actually about 6.4 grams across all 8. But again, you can pair up on each throw of the crankshaft. Since there's 2 rods on each throw of the crankshaft, you can strategically pair the heaviest big ends with the lightest big ends again on each different pair, or whatever you want to call it. And by the time we did that, we ended up only 0.4 grams across each pair of big end side of the connecting rod. So again, well within 1 gram of balance across all 8. There's kind of 2 ways of doing things. You can do a bunch of grinding, remove more material, and get them all exactly the same, or you can be smart about it and mix and match things a little bit, and you don't have to do as much grinding. You don't risk any damage to the connecting rods, any damage to the pistons, and so on, because you're doing a very limited amount of grinding on all of them, and you can still come out with a really balanced assembly. So just for fun, I wanted to address the question that we get, because I posted a short of doing this process a couple weeks back, and we always get the question, why don't you just stick the pin in the freezer? And I think what people understand is that you put something in the freezer, it gets cold, it contracts. You put something in the oven, it heats up, it expands. So they have this concept that if maybe if you just put the pin in the freezer, it'll slide right into the connecting rod and you don't have to heat up the connecting rod. So I wanted to show you guys why that's just really not super feasible. So I've got two of our pins here. My gauge is a little bit off, but I've set up our bore gauge here so that we can measure the 0 point. So 0 right there is the exact diameter of our piston pins. Now our connecting rods here, since it is a press fit connecting rod, this bore should be smaller than those pins are. And if we measure it here, we've got just under 1.5 thousandths press fit on that one. Let's check another one. They should be all kind of in the same ballpark, but just to be sure. 1.2. I think general recommendation is negative, 8 thousandths of an inch to 1,000th and 2/10. So we're actually slightly over what kind of the minimum recommendation would be. So you're like, okay, that sounds easy enough. 1.5 thousandths, that's not a crazy amount to overcome. So let's calculate how much this pin is going to shrink by putting it in the freezer. In the shop here right now, we're about 72 degrees Fahrenheit, it looks like. The average household freezer sits at a temperature of about 0 degrees Fahrenheit. If you have a deep freeze, it might be, a little bit colder than that, but the average household freezer, you're right around 0 degrees. And this calculation probably has a few assumptions taken into it, but it is fairly accurate. So our pin diameter is 0.912 inches. The temperature difference, let's even give it 72 degrees. We'll say we'll go from 72 degrees to 0, so our temperature difference there is going to be 72 degrees. Our thermal coefficient of expansion for steel is this value here, this 6 to 6.94, depending on the composition, but overall we're just going to make the assumption that it's steel, and we'll go conservative, we'll give it a little bit extra, we'll call it 6.94. So that's what this value here is, and if we calculate that, the circumference of that pin is going to change by 1,000th and 4/10. Okay, so how do we figure out diameter? Well, C equals pi times diameter. So if we divide our 0.00143 by pi, that pin is only going to shrink by 4.5 ten-thousandths of an inch. And again, we have close to 1.5 thousandths of press fit here. So you're only getting about a third of the shrink that you would need to have a 0 fit, and realistically you need significantly more than that to be able to have clearance to press that pin in and get it all the way in before the temperature equalizes. So that's where, if we're putting it in the torch, let's say we go from 70 to 470, just as a ballpark. Let's say we increase it by 400 degrees. That's going to increase our size to 915 thousandths. 0.0795 on the circumference. That's getting us upwards of 2.5 thousandths increase in the diameter of the small end of the connecting rod here, which again gives us about 1,000th clearance to be able to slip that piston pin into the rod. It's not that people are wrong by saying that you could put the pins in the freezer to gain a little bit of an advantage, but it's still not a large enough temperature differential to accomplish what we're trying to accomplish here. So that's why we use a rod torch. That's why this is the industry standard, is to use a connecting rod torch or an induction heater to mount press fit pistons. So again, for those that have never seen this done, what we do here is the torch will be on here, and we'll slip the connecting rod so that the small end is right on the torch, and we'll heat it up for just about 20 seconds. We don't want to go a whole lot more than that, but much less than that, and you're not quite getting enough heat put into the connecting rod. And then this jig here is set up so that hopefully we can slip the connecting rod down in, push the piston pin through, and the piston pin will stop right here against that stop, and hopefully that will get our connecting rod centered on the piston pin so that it's not lopsided to one side or the other. Honestly, there's quite a bit of play there that is acceptable, but we still try to get them as close as possible. So let's get started here. You guys didn't actually think I was going to do that, did you? As far as I can tell, I've got these all laid out the correct direction. I'm going to oil the pins just a little bit. Whoa, a lot of it in that case. This oil can is being kind of annoying. Just work that back and forth a little bit. We'll do the first connecting rod, make sure it looks like it's on the correct direction and so on. Make sure that it looks like it's centered well, and then we'll try to roll through the rest of them. Ah. Wow, that was not graceful in the slightest. Appears to be mounted correctly. I was pretty close, but I'm going to move this the slightest amount. Probably regret that. Now I'm slightly too far the other way. Pretty dang good though. Actually, that looks pretty good. I'm gonna try 15 on this one. Actually, I'll just do 16 or 18 or 20. Oh, that was close. You know, the internet is full of trolls, but I would never stoop to their level. That came out really nice, actually. Let's put them all to the front here. See, you get your first one set, and it's like, well, you know, I think I could adjust the stop a little bit because it's ever so slightly out that way. So then you adjust your stop, and you get the opposite effect. But it all just kind of depends on the casting. The area where the rod hits the side of the pin boss there is not always a perfect surface. So you have to get your stop set close, and then you have to hope that the rest of them turn out great. as long as you're not like more than like an eighth of an inch off, you're going to be fine. If you started, getting more than that, you're definitely going to have problems. But I would say we're all very close within reason here of being centered. That one might be a little bit biased to the back, but that's just kind of the difference across all 8 of them that you come up with. Just for reference, if your rods come back looking like that, might not be the best idea to run them. But this is what you want them to look like. Just double checking our orientation here. Taking a look, 1 and 5 are pairs, 2 and 6, 3 and 7, 4 and 8. So the larger side of the chamfer on that rod should be backwards, forwards, backwards, forwards, backwards, forwards. Some of them hardly have a difference from side to side, but still. Forwards, backwards. You can tell that because the larger chamfer side is supposed to clear the radius on the crankshaft, whereas on the inside, it's butting up against the other rod. It doesn't need as large of a chamfer. But this thing's coming together pretty well. In the next video, we'll probably be setting up the bob weights and balancing the crankshaft, then polishing the crankshaft, and at that point, the short block here will be ready to go together. So we're pretty well on our way. I think our parts are ordered for our cylinder heads, so that may be the next video as well. I'm not sure exactly what order everything will get done in here, but for now, I'm headed on a little vacation to take the daughter to see her grandpa in Texas with my wife. Hope you guys enjoyed this video. It might be a little bit shorter than normal, but be sure to like and subscribe and stay tuned for the rest of the 289 build. It's just like the 400 rods I did the other day. I do the first one and it's not quite centered like I want it to.
Yeah.
So I adjust it a little bit and then you get to number 3 and it's the opposite. I think that's when you know that you're pretty dang close to center because it just varies from rod to rod because of the casting.
Yeah, and you can't reset that fixture
Very accurately.
Well,
yeah, you can't do it for every single one.
yeah, you could, but it kind of defeats the purpose of having it if you have to do each one individually. But yeah, they look like they're the way they're supposed to be.
If you had a set of pistons that was actually nicely machined in the pin boss, then it wouldn't be an issue. You could set it really easily. But if you have a set of pistons that's nice enough to be nicely machined, you're probably doing floating pins.
Yeah, you probably would be.
Looks okay.
What's wrong with this one?
That's what not to do.
Oh, okay.
That's clickbait.
Oh, we'll see what happens.
I commented that there's lots of trolls on the internet, but I would never stoop to their level.
I'm glad to hear that with this as proof.